I've got an hour to kill, so I guess I'll stream. What I what I did yesterday was I basically set up like models for all the various information that we're going to need to store on the server. And I also selected the library that we're going to use for dealing with WebSockets. And yeah, I didn't get very far because I was waiting for things to install and stuff like that. But I have an idea of what I want to do today. So I guess first off, let's just create a like a web let's just get WebSockets working. Uh, right. There's a WebSockets library, and this package is what we're going to be using. Uh, hmm. Okay, yeah, let's just do this. I'm gonna get rid of that for a second. So some sort of connection and forever do. Okay, so this connection, that's what we need to be using here. I'm not sure how we get the connection though. How about we look at example? And nope, that's not the right one. I swear I looked at something yesterday that was. Huh. I remember looking at a literate Haskell file. WebSockets GitHub LHS. There we go, server.lhs. So this is an example of a file, of a WebSocket server. I already looked at it a little bit yesterday, but I haven't actually created a server yet. So that's where you can see all the server state and the client stuff is coming from. So yeah, so this is how you create a server. So you have a entry point, like I said yesterday, and it's called main. So Haskell, it first runs this function. I don't want to deal with state right away. I just want to get something working. So if we look at the documentation, there's a function called run server. Yeah, run server. So this is the run server function. It takes a string, an int, and an application. I don't know what an application is. I guess doesn't look like there's an application thing in here. Maybe it's an import of some sort. Oh, okay. So application is a function that takes a state and pending. So pending is also used here. So this is where Haskell's type inference kind of bites you in the ass, because you have to look at the documentation a lot. What you could do in this situation is do something like application and then just put the type before here. So put a type annotation on top so that people know what's going on without having to read all of this documentation. Like what this. Oh, he already did it. He already did it. Never mind. Okay. So it takes a mvar and a pending. I don't know where the pending is coming from though. Oh, okay. So it returns a. Yeah, but I don't. maybe I should be looking at the type annotation for accept request. I guess this is where the whole thing starts. So when you fire off a request at a WebSocket, it goes here. Takes a pending connection and then returns a connection. So, oh, okay, pending is a pending connection. Okay, so this is a connection. Cool. So I need to have a ws.run server and then specify the address. I'm just going to put it on localhost. And then I'm going to specify a port. I'm just going to say 8000. And it still needs, run server needs a server app. I don't know how to construct the server app. Oh, it's a pending connection to an IO. Okay, so that's how they're constructing it here. So let's just I'm not fond of like doing type aliases for everything, because like I don't like going back and forth, because I don't remember what this is, but they've already specified here. So I'm gonna just do that here. Application takes in, I don't want to take anything. It's going to be a ws.pending connection and returns an IO. Okay, and application pending equals do. So we need to put something here that does something with this pending connection, and then just like delete it, and then just that's it. You just do something with it. You don't have to return anything. Oh, so you get, okay, so you can do, so now that you have a pending connection, you can pull that out by doing, so you can pull out a connection from this pending connection by doing ws.accept request. So that's how that worked. Okay. All right. And and we need to do ws.fork ping thread. So I'm assuming what this does is it continually pings pings the client, or replies to pongs. I don't know how that works, but it continually pings the client in a separate thread. I think it's called a spark in Haskell, or is it? I think it. Sparks are not thread, but more of a unit of computation. Oh, it's for parallelization. So we're still using threads right now. Right. So fork IO is a lightweight thread. Okay, cool. So it's not a spark. So it's going to keep pinging until forever. I don't know. Oh, I need to specify the application. Did that work? Yeah, don't need the do. I still want to. Hello. I need some music.
When I was little, my father was famous. He was the greatest samurai in the empire.
Okay, so I've got running server. Let's see how this works. Let's do Cabal run. It's got a compile and run. It shouldn't be too long. Huh. Okay. So I don't need this here. So what it's complaining about is that it doesn't. I've sorry about that. Turning down the volume. What it's complaining about is that I have a import here, but I haven't specified where to import that from or which packet. I haven't specified the dependency. So I mean I don't think I need it anyway. So I'm just gonna get rid of it. Okay, it's compiling, linking, and I think it probably already. No, it should say running. Running server. Huh. I wonder why it's. It must be the stream that's causing it to be so slow. I wonder if I'm doing something wrong. I wonder what's wrong there. It's just taking a long time to link. So I need the gold link. I don't know what's maybe. Oh shoot! It was actually running. So okay, so it wasn't the linker. That was my fault. So what happened here is that. Okay. God damn it! Sorry for swearing there. Right. So what happened is this thing is blocking this line of execution. So it gets to here and then it doesn't do anything. So what I need to do here, I can do it in a different way. I'm going to do fork. I don't want to fork IO. I want to block this main thread. So I can do fork. No, I don't need it. I'll just put it on top. So that I know that it's actually running. Running server. Great. So yeah, that was my fault. It wasn't Haskell being mean or anything. Or GHC rather. So let's try connecting to this. Okay, so it's complaining that there's a malformed request and I'm missing headers and stuff like that. It's all good. I'm gonna Cabal run again. What I need to do is maybe I should use Node for this. Yeah, I'm gonna use Node. So I need a WebSocket equals new. There's there now autocomplete here. Okay, that sucks. Okay, let's just go back to Chrome then, if that's the case. Var ws. Now I'm just gonna call it sock equals new WebSocket. I think WebSocket takes a address of some sort. Localhost 8000 sock dot something. Ready state, that's what I need. Ready state. Connecting? Nope. Open. No. So there's a header missing. I don't know what's causing that. Keep alive. Maybe I just need to rerun it or something. Sock dot. And okay, maybe. Okay. So here's how a WebSocket works. There's a socket.send function that you can call, and I think it does it asynchronously. So it sends some data over to the server, and then and then the server sends back data, and you can put a listener on the socket and stuff like that. But let's just do something here. What am I looking for? I just want to look at the documentation for this. Okay. WebSockets reference. That's what I need. WebSocket. Okay. There's a send method. That's what I need. So it takes in a string to send to the server. Okay. Let's do that. Hello. Oh, it's closed. Oh, I guess it's not pinging. That's probably why. So what's happening here? Okay, so why is it closed? Am I running it on the wrong soft thingy? 8,000. Oh, maybe it's the extra slash. Hold on. Dang it! 8,000. Oh, maybe it's this thing. It should be 0.0.0. This just makes it public, so everyone on my network can access this now. It's listening from the outside as well. What? Okay. Maybe I'm doing something wrong here. So there's a... Not sure what's going wrong here. I don't need to do any of this. I just want to be able to... Yeah. Maybe I need to do... Maybe I should look at here. Look at the functions that I have to use. Because I've just been copy-pasting for a bit now. Send, receive. Send ping, send close. So I need to do something here, probably. Okay, maybe I need to do WS. Send a ping. Takes a connection and a WebSockets data. I don't know what that is. Okay. Maybe I did something wrong here. Send ping. Ping. Fork ping thread. That's what it is, sorry. Fork ping thread. Okay, so what am I doing wrong here? I don't need all of these error messages. I am lost, to be honest. Maybe. So I've accepted the request, and then I've got a connection, and then I fork the connection, fork a thread to continually ping that thing. So what's wrong here? Maybe I'm not. Yeah, maybe I need to do fork IO. I don't need to import it. Okay. So fork IO takes a. It's basically Haskell's way of creating a new thread. Oh, I don't have it imported. Import control.concurrent. Okay, so I can do forever do. I need to find forever. Okay, so there's a thing called Google, which is, as you can guess, oh no, that's not it. Stackage. There's so it's basically a search engine for looking through stackage.org. Okay, looking through Haskell functions and yeah, all yeah, type classes and stuff like that. Just looking for, you can actually type in a type signature like they have here. So I can do A to A. I guess that would be like an id or something. No. Identity functions. Oh yeah, okay. That is an identity function. But like I can type in fork IO and it'll get me fork IO, or I can type in IO empty IO thread ID, and then it'll give me all of the different ones. Fork okay, cool. So I can type in, what am I doing? Forever. So there's this function called forever, which is basically like a loop in, it's like a while true loop. So I need to import it from control.monad. Import from control.monad forever. So when you put the brackets, what that does is it only imports this thing into the current namespace. So I've only got forever in here. Huh. So I need to. There's something wrong here because maybe I do. I'm just gonna put something here just as a placeholder. So there's something wrong here. Maybe I forgot a thing. Yeah, that wasn't the problem. Yeah, I don't need that. Maybe I can put a dot there. Will that work? Oh, yeah, it works. So I can put a dot there as well. So what this $sign does is it combines the functions so that like it just combines everything after that $sign into one thing. So this entire thing is is one unit. I don't know. Hmm. I'm not. You're right. I need to send data continuously. I'm just gonna try that. See if that does anything. Maybe I'll like get an exception or something, and I'll be closer to my problem. It's like I'm it's entirely my fault. Like I it's I shouldn't be doing it this fast. Like I should be going through the source and like coming up with a different sample application to test out the library first before diving into it. But whatever. Yeah, I should have done that instead. Data message. I just want to write a string though. What's a message? Constructors colon control message takes a ping and a byte string. So I can do a text. Okay, let's do that. I don't know what kind of byte string though. Bytes data.bytestring.lazy import data.byte string dot lazy and then just import byte string from that. So what a byte string is when you have a string in Haskell, it's normally represented as a list of characters. So A, B, C. These are all characters, and this is what a string is. So if let's just go into GHCI and type in a string of some sort. Let x equal ABC, and let's look at the type of x. See, it's a list of that stands for characters. So the problem with this is when you're dealing with very large strings, it's really inefficient to have to point to every single one. It's better just to say the string is this many bytes long, and this is where it is. So and like point to the place in memory where it is, rather than like have each character pointing to the next character like a linked list. So I guess that's what byte string does. And not like underneath, it's not represented as characters. It's represented as bytes. And a lazy byte string, it's not. I think it means that it's not all loaded in memory right away. So you're if you're using it, you're continuously pulling it into memory. It's not like an iterator in that in that way, because it stays in memory. So I think you can like seek backwards and forwards, whereas with iterators you can only go on one direction. So we need to send something. We need to send some sort of message. Yeah, teach these sockets a lesson. We need to ws dot text. I think that's the right one. Dot text. Yeah. So there's a language extension called, I don't remember how to do language things. Overloaded strings. I don't remember if this is the correct syntax. Haskell overloaded strings. So it's called a syntax extension. So it's like it basically what this syntax extension does is wherever there's a string and you need a byte string, it'll just automatically convert for you without having to do anything special. I don't remember how to add it though. Oh, I got the thing. It should be, right. It should be that first and that second. There we go. So I can just type in ws.text and then put in a string here. Hello, and this is just gonna, I think it's gonna just spam it. I wonder if there's like a sleep thing. I'll look at it later. So I need to send a text data. So I'm just going to send a message. ws.send con. So we need to provide a connection and then a message. Did I do something wrong here? So I messed up here somehow. Couldn't match type ws.message with actual type data message. So we need to send data message instead. Send data message. Will this actually work? Right. So put stir ln sent hello. Cool. Everything seems to be fine. Oh, okay, yeah. Yeah, looks all right to me. This is pretty much what we want. I don't even think you need the, yeah, I think you do need the, I don't think you need the fork IO part. So if I do just forever do, and then put this there, I think that should be good. Don't even need the fork forever. I mean the fork IO. Cabal run. Let's do this. Oh, right. So this is what I was talking about earlier. If you've already got the package installed, like I think Cabal will recommend which package to add to your dependencies list. So build depends, and I don't think I have the latest one, so it's gonna complain about that too. Just gonna get rid of that. I don't like unnecessary spaces. It's called byte string, and it should be 10.0. Byte string. What did they use in here? What's the latest one? 10.4. Yeah, I've got the latest one. So I don't have to wait. I don't have to wait to build all of that. 0.9. Sorry. 0.10.4.0. Yep. I can just do cabal run. It'll configure this again. So if I didn't want to do this, if I wanted to check if I wrote everything right in here, like if I've got my commas and spaces and all right, then I'll just do cabal configure. Okay, so everything seems to work. It's complaining about there not being a license file, but I'm not going to open source it, at least not right away. I just want to get far enough with this. Oh, why am I configuring again? Cabal build, that's what I need. Okay, so that built, cabal run. Oh, this is going to be ugly. Yeah, yes, allow that. So let's see how this goes. Okay, so it's definitely sending a lot of messages there. We don't need to do that. We need to soft dot on open on message. Okay, let's. Maybe there's a Haskell sleep function. That's what I need. That would limit that. I could have just looked it up in Google, so I could have done sleep. So there's two Hoogles. There's Haskell.org dash /Hoogle, and the difference between this and the Stackage one is that Stackage has a whole bunch of other third-party packages that it looks at as well, whereas Hoogle just looks at the standard library. So what does the sleep do? Control the thread delay. That's what I need to use. Thread delay suspends the current for a number of microseconds. Okay, let's do that. Thread delay 10 microseconds. So that's smaller than that's 1,000 microseconds is a millisecond. No, whatever. It's all. I guess I'll just put in like 50,000 or something. It'll be fine. I need to import it from control.concurrent. Delay. The server is running, and what I need to do now is I need to do sock.onMessage and then make it a function. I need to assign it a function that goes something like function. Oh, I think there's some sort of data that I get. I don't know. I've never done that. Data. Oh shoot! It actually works. Okay. Okay, we need to shut up, shut up, shut up. So we're getting some data here. It's pretty good. I still don't know what was causing that problem from earlier, but I suppose it doesn't matter anymore. Maybe I need to put in. Let's just find this out. Microsecond to 2 second. 1 million seconds. Okay. Oh, micro. Okay. Yeah. 1 million. So 1, 2. Yeah, that's 1 million. And let's just replace that with 5. Okay. Let's run that again. I'm actually surprised it's compiling this fast considering I'm streaming as well. Allow. Okay, you know what? You know what? Just this is exactly why I wanted it to run on localhost 127.0.0.1. This way it doesn't bug me about going outside. So maybe I got the localhost 27. 127. Yeah, that's the way I wanted. Oh, okay, it worked. It just took a couple seconds for some reason. Oh, it took 5 seconds, right? Right. So it's actually sending me a message every 5 seconds. We need to do something like this with the program. So everything seems to be working. This application part is where we're gonna put stuff in. Like, yeah, I don't. Um, let's look at the deobfuscated source. Why am I looking at it this? There we go. So if someone so they're using something called parse, which is I believe it's a backend as a service application. I've never used it before, so yeah. I'm just looking for the entry point now. I don't know where it starts. Oh, maybe I should look at where the WebSocket is, because I remember using the on message function. No, on message. Yeah, there we go. On message. So I guess what this open function does is if it takes a URL, so in our case it would be localhost, and if the WebSocket's already if it's not open yet, no, sorry, if it's already open, then it just closes it. And it sets all the data, and it creates a new WebSocket. Okay, so we need to call it an array buffer. Okay. So there's a parse function that we need to use. So there, and the listener. Okay, so the listener is where it starts. So when this finally opens, it's going to send us a bunch of data. So it's going to send us an array of these two things. I wonder if there's a data view thing for Haskell. I don't think our data view is there. Maybe I think it's called a byte buffer. Byte buffer Haskell. Binary parsing. Once you have your data, okay. I don't need to I don't think I need to parse it, but I do need to. Do something with this. I need to. So I don't know if there's a byte buffer function here. I mean, other useful packages maybe. Network byte string. Maybe this is what I need. Network byte string. Yeah, let's look at that. In favor of network. Okay. Network. This package provides a low-level networking interface. So what can I do here? Let's look at. I don't. Let's look at byte string. But I don't need a string though. I need a. Like I need a way to send arrays basically. Oh, vectored IO. Okay. Receive. No, I don't need any of this. I just need the data structures in here. They have some sort of I guess they just use strings, byte strings. Yeah. Dang it. I don't need to deal with strings. Damn. I might. So You know what? First, let's just get some. Let's get this working so that I can actually receive data on this. Yeah. So right now we're sending data. Let's receive some data. I want to put it in a different thread. Let's call it No, same thread should be fine. So if I let's receive. Nope, I don't need exceptions. There's a synopsis thing here. Let's see if that does. Yeah, so it gives you a list of all of them. What do I need? Accept request? Nope, I need to receive data. I need to receive a data message. Okay, let's see how that. So it's a connection. So it just receives it. Okay, cool. So I guess what I need to do is just block on this until I receive it. ws.receive I before E. Dang it, E before I. Okay, data message con, and then it's the same kind of thing where I specify the connection. I forgot. I think I need to do case of. Shoot, I don't remember. And I get a IOA. Oh, okay. So I need to. First off, I need to pull this stuff out. I need to pull it out of that IO monad. So I'm gonna do that. So it's just gonna wait until something happens and then pull it out. And then I'm gonna do case message of. So there's different kinds of data messages. There's a text and a binary. So there's only two. So I'm gonna do some kind of text. So it's a text ws.text, and it's going to be a message. And this is just a function thing here, and it's pretty nested. I know it's ugly, but what are you going to do? I feel like I can clean this up a little bit more later. Doesn't need to be on a different line, I don't think. So what I could do is put a dot here. I think that's prettier, since whatever. Oh no, that's not what I need. What I need is a thing here. Everything seems to be okay. So if, well, what I also need is a if-then thing here. So let's start it out here. If message equals, I don't know, ping. I don't remember how this worked. Maybe I need a then here. I'm sure it'll complain if I. Whatever. I'll just put it in here. Then will it work? Of course not. Okay, hold on. I think it needs to be on the same line. That's the problem. So there's something wrong here. Let's look at this. Haskell. Oh, no. I could just pattern match here. So I could do ping. And there's no need to use if statements. Cool. Okay, so I can't believe that took me that long. But what happens here is that if it receives a capital P ping, then it'll respond with a pong. That's essentially what this fork ping thing is doing, I think. Let's do that again. Console.log. That's right, so there's nothing happening here. I need to run the server. Running server. Yeah, that's pretty ugly. I just want to do it again. running the server. Okay, type this in again. And we need to send something to that. Sock.send. What can I send? There's got to be a thing. I don't know how to send strings. Maybe I should look at this file. Hold on. This file. Maybe there's some sort of text thing. There's a context. Lots of context. jQuery text. Okay, there's a lot of context. Okay, you know what? This is not gonna work. WebSocket. Oh, this is the same page as before. What am I doing wrong? Maybe I should look at the tutorial. And there. Is it DOM Spring? Okay, so I just type in text and I guess it just does it. So I can send it as a string, blob, or array buffer. What they seem to be using here is an array buffer. Yeah, and then they basically just set the stuff inside of it. Okay. Let's do that. Okay, I'm gonna go here. Ping. And I got a pong back. Yay! Okay. If I send another one, and another one, and another one, I'm not getting anything back. It's taking a while. I wonder why that is. I probably put the sleep in there still. That's probably why. Yeah. Oh my god, that was not a good idea. Okay, you know what? Let's do that again. It should. I wish I didn't leave that thing in there. Because like it doesn't matter because it's blocking here right anyways. So until a message comes in, it's not gonna move forward. Wait, can I do sock.onMessage equals console.log? Is that possible? Yeah, okay, that's not possible. Okay, never mind. What is +3? Oh, it's the minor mode, okay. Cool. I guess we have some sort of thing working. We have a way of sending messages back and forth. I don't think I need. I'm just gonna get rid of this for a second. I kind of. Whatever. I'll just get rid of it. I hate type aliases, anyways. I'd like everything to be explicit if possible. If it clarifies something, or if it's something you don't need, then throw in a type alias. But other than that, it's pretty annoying. Like I'd rather just go with the complex types, unless I'm throwing it around all over the place. So if I just memorize it once, it'll be nice. Okay. I guess we don't need the import. We don't need. I'm gonna keep the thread delay in here. So what do we have so far? We have basic server. We're binding on localhost, receiving a ping and then returning a ping, and then dealing with the other ping thread thing as well. And we also have the models from yesterday, so I feel pretty good. I got a lot done in an hour. All right, see ya.